Hello guys, good morning. Today's class we will discuss named pipe. It is one of the IPC mechanism. Okay, so previously we discussed the pipe. So that is one type of IPC mechanism. This is next one. Its name is named pipe. Okay, it's also called as FIFO. Also called as FIFO. Before going to discuss about this named pipe, first I will list out the functions involved to implement the FIFO. Okay, and next followed by overview of FIFO, and next we will see the one task related to the named FIFO. Clear? Okay, first we will see the functions. What are the functions involved in this IPC mechanism? Here I am writing FIFO. First one, mkfifo or mknod. Next, open, read, write. Clear? So these are the functions involved in the named pipe. Okay. Here we will see a simple single line definition about each system call or each function involved in the named pipe. First one is mkfifo or mknod. See, this is the function we have to use to create a FIFO. This is the function we have to use to create a FIFO. Okay, we have two functions are there. We can create named pipe by using mkfifo or mknod. Okay, in this class we will see what is the difference between mkfifo and mknod. Okay, coming to the next system called open, read, write. So you all guys know about these three things, these three system calls, right? Like open is used for to open the file, and read is used for to read the data from the file, right? Like that. So these are the basics only. Okay, now we will see the overview of named pipe. Okay, overview. Okay, for that we have to, yes. So before going to see the overview, I want to tell you one thing. This named pipe, see, what is IPC? We already know. So IPC is inter-process communication. Why we have to use IPC? Because we have to use to exchange the data from one process to another process. Okay, that is the purpose we are using IPC mechanism. Okay, so for that we already discussed one second, we already discussed about the pipe in previous classes. Then why we move to named pipe? Why we move to named pipe is also called as FIFO. Okay, it's also called as FIFO. Why we move it to named pipe? The reason is one second. The pipe what we discussed in previous class will support only so will support only relay to process communication. Okay, so in last class we started discussing on pipe that will support only relay to process communication only, but coming to named pipe, it will support unrelated process also, unrelated process communication. That's why we are moving to named pipe. Okay, so I think you already know what is relay to process and what is unrelated to process. Just I am giving one small example. Like, so relay to process, in the sense relay to process, it means like by using fork, if you create a child process, so the parent in that situation, the parent and child, they are related to process. Okay, when you create a process by using fork system call, the parent and child is a related process. Unrelated process in the sense, I will show you. 1 second. I open two terminals. One second. Yeah, 1 second. Yeah, I open two terminals. In one terminal, let's say P1 process is running, and another terminal P2 process running. So if you want to communicate between from one process to another process which are running in another terminals, is called unrelated process. That's why we are using FIFO, is also called as named pipe. Okay, to achieve communication between unrelated processes, we are using named pipe. Okay, I think, is it clear, right? Just see this one. Why we moved to named pipe? The reason is the pipe what we discussed earlier, it will support only related process communication, but named pipe, coming to named pipe, it will support unrelated process communication also. Okay, so you understand, right, what is unrelated process communication? It means if process are running in another terminal and in another terminals, even though we have to achieve the communication between the two processes. Okay, those are unrelated processes. Okay, now we will see the overview. For that I am opening the man page. Okay, so man 7 mkfifo. Okay, man 7 FIFO. Yes, so once again, yes, man 7 FIFO is a man page. It's a man page. It will give you the overview of the FIFO mechanism, FIFO IPC mechanism. Okay, let's see. Yes, here description is there. Here we will see the main points. Okay, first thing, a FIFO, read with me. A FIFO, a special pipe, is also called as named pipe, is similar to the pipe. Okay, first read up to here. A FIFO is a special pipe. It is also called as a named pipe. Is similar to the pipe. Okay, see what they are telling is this FIFO is there. This FIFO is also called as named pipe, and it is very similar to the pipe mechanism they are telling. But except except that it is except that it is accessed as a part of the file system. What they're telling, the FIFO is very similar to the pipe, but there is one condition, except that the FIFO is accessed the part of the file system. Okay, I will give you the clarity of this one. One second. Yes, in pipe, what is there? Just like in previous class we discussed a pipe has two ends. One is read end, one is right end. Right end. Read here, right end. So what's happening here? What's happening? The pipe is nothing but it's a buffer. It's a buffer. Whenever you created a pipe, internally a buffer will created that present in the kernel, right? That is pipe. But coming to the named pipe, coming to the named pipe, what's happening is one file is created in hard disk. Okay, one file is created in a hard disk. Okay, so that's why here they are telling it is as a part of the file system. So what they are telling is, in normal pipe there is no files are created, there is only one buffer is created in the kernel. But coming to named pipe, one file is created. That is the difference. That is the difference between the that is the except that in the named pipe. Okay, let's see what is that. It can be opened by multiple process for reading and writing. What it refers to the file. That file can be opened by multiple processes for reading and writing. Okay, see I will tell you. See I will tell you one second. The FIFO is there, na? The FIFO is a one of the IPC mechanism. Okay, so here whenever you create a FIFO, one file is created in the hard disk. Okay, that file can be opened by multiple processes. Why they will open? For reading and writing. Okay, now see this point. When processor exchanging the data via the FIFO, the kernel passes all data immediately without writing into the file system. Okay, I will tell you. Just read this point again. When processor exchanging the data via the FIFO, the kernel passes all data internally without writing into the file system. See what it means. I will tell you. Yeah. See, when you created a FIFO, what will happen? One file is created. File is created. Where it will create a hard disk. Where it will create hard disk. Okay, let's say we have two processes, P1 and P2. P1 is running in one terminal, P2 is running in another terminal. Now P1 wants to write data. P1 wants to send data to P2. Okay, this is the requirement. What will do P2? What will P1 will do? Write data into here. First P1 will open the file in write mode because it is writing, and next it will send data to here. and P2 will open the file in read mode because it is reading. Okay, so after that it will read. See what they are telling is, when processes are exchanging data via the FIFO, the kernel passes all data internally without writing into the file system. It means, see, in this file there is no content. In this file there is no content. Just it is access point. Okay. See, just P1 is writing into the file and P2 is receiving. It will not store the content into the file in this file. Okay, so it will store in just some buffer in the kernel. Okay, so the size of this file is 0. The size of this file is 0. Okay, next, thus the special file has no content on the system. The file system entirely may serve as a reference point so that the process can access pipe using in the file system. See what they are telling is, there is no content here. There is no content in the file system. Okay, just it is a reference point. For the all processes. Okay, for the all process. Okay, see, don't be confused. First time it will be confusing. Once we will do the task, then you will understand. Okay, is it clear, right? Just read out multiple times, you will understand. Nothing, there is no complexity. Okay, now yes, okay, 1 second. Yeah, and one more thing I want to tell you, for creating FIFO, we can do in two ways. One is command, and second one is system call. Okay, first just I will show you by using command. I will create a FIFO. That is, command is mkfifo followed by file name f1. See, here we got. I will show you. Yes. So this is the file created, and we already know, right? So first character will tell the type of the file. We already discussed. What is that first character? P. So it is a pipe file. Okay. And one more command also is there. That is mknod f2 underscore t. Let's say I will show you again. See, f2. What is the type of the file? P. So it is a pipe file. Okay. So what's the difference between mknod and what's the difference between mkfifo? See, both are used for creating pipe files. Sorry, both are used for creating named pipe. So what's the difference is, the mkfifo, it will only create pipe files, or in the sense named pipe. But mknod, see in the syntax what we are doing, first command, next file name, and next we are giving type of the file P. But coming to mkfifo, are we giving type of the file? No, just we are giving command next file name. But here mknod, we are giving command, we are passing file name, next we are giving type of the file. So what the difference is, mknod will create multiple type of files. Okay, but mkfifo, it will create only one type of the file. So that's the only difference between mkfifo and mknod. Okay, now I will remove f1 and f2. Okay, that's the only difference between mknod and this one. For your understanding purpose, I will create here. I will not. Sorry, I will write down difference between mkfifo and mknod. mkfifo, it's a library function. It's a library function. mknod, it's a system call. Here I am listing down the differences, main differences I am listing. Second, it will create only pipe file. Okay, but mknod, it's create another type of create another type of file also. It's create another type of file also. Okay, what is another type? Those are pipe file or character file or block file. Okay, so by using mknod we can create pipe character block files, but by using mkfifo we can create only pipe file. And one more difference is mkfifo is a library function and mknod is a system call. And you already know library function internally called system calls only. So yes, this is the difference between mkfifo and mknod, and we already see an overview. And the main difference, remember guys, the main difference between pipe and named pipe is pipe will communicate between relative process only, and coming to named pipe, it will communicate between unrelated process also. That's the main difference. I think you guys got to you clear. Now we will see the task. Task is very clear. It is very simple. Here we will create two processes, parent process and child parent process called as P1. No parent process. We will create two processes named as P1 and P2, which are running in different terminals. Okay. Now P1 process has to read the data from user. Okay, by using scanf. Okay, and sends the data to FIFO. Okay, this is the task of P1. Next, P2 process reads the FIFO and prints on the screen. So this is the task. It's very simple task. Okay, so what the task is, we have to create two processes. Those names are P1 and P2, which are running in different terminals. Okay, now coming to P1 process. P1 process has to read the data from user in the sense ours, by using scanf function. Okay, and after reading the data P1, it has to send the data in FIFO. Okay, next coming to P2 process. P2 process read the FIFO and prints on the screen. Okay, so this is the task. Now we will do. Okay, this is the basic task. One second, guys. Okay, so here I create. Okay, before going to that, we will see the function. Sorry, by before going to do that task, we will see what's the system called to create what is the prototype. Okay, so we already seen by using command how to create, right? Now we will see by using system call how to create. For that we have to open man page, man mkfifo. Okay, so just see, so this is the prototype. Okay, this is the prototype. This is the prototype to create a FIFO, create a named pipe. Okay, so what we have to pass, two things. One is path name and second one is mode. Okay, so path name is nothing but just a file name. Okay, and mode is nothing but what is mode? Just permission. Okay, just permission to that file. Okay, so for that, for using this function we have to include these two header files. One is systypes.h, second one is sysstat.h. Okay, clear, right? Here just to see this description. mkfifo makes a FIFO special file with the name path name. Okay, see what they are telling is mkfifo function is there na, that will create a special file with the path name. Here what we are passing the path name, that is the name of your file. Okay, next mode specifies the FIFO permission. Okay, means you already created one file by you file it, for that you have to give file permission. Okay, now we will start a code here. Okay, one second. So I already created header file. In that I included what are the main header files, what are the main header files we are going to use in the program. So that's why I created one header file.h file. In that I included. Clear? Now we will write P1 code. First thing what we have to do, we have to include user header file. Next, first thing we are creating a FIFO by using system call mkfifo. So file name I am giving f1 and next permission I am giving 0664. Okay, now I am just checking P error. I think you already know about P error, right? Now I am now discussing, that is basic concept. P error, what I am doing, FIFO. Okay, just we will run here. Just we will create FIFO. We'll see what's the output. cc p1.c p1. Oh, sorry, that header file name is different. Header file.h. We written header on. We have to update header file.h. Yes. Now we will run the code. Yes, success. Just we will see F1. So FIFO is created. Yes. FIFO is created. Now one more thing, if I run multiple times, what will happen? Just see, what's the P error it's showing? File already exists. File already exists. See what means? One second, I will open the code. So in the code nothing is there. In line number 6 we are creating, and line number 7 we are just printing the error message. Okay. So what they are telling, first time if FIFO is not there, if FIFO file is not there, first time it will create and we got success message. Okay. If I, okay, we got success message. Again I run here. What's happening? We got a message like, error message like, file already exists. Okay. So what happened is, if file is not there, mkfifo function will create. Okay. If file is already there, it won't create. It will give error as a file exit. Clear, right? Now here I will comment P1. So what's the P1 task? P1 task, it has to read the data from user and put it to FIFO. So this is the task. Okay, now what we have to do? We have to open a file. To put the data, to put the read data into the FIFO. Okay. So you already know open system call fd equals to open. What we have to give? We have to pass two arguments. One is file name which you are going to open, and next one is mode. Like we have to pass flag. Flag means if you are opening for write only, you have to pass o underscore wr. One second, we have to pass caps underscore wonly. Okay, that's it. Okay, here we are line number 12. We are opening the FIFO. Okay, so I one second, I will tell you important point here. One important concept is there. I will show you. Okay, see what we are doing. I am explaining the code. In line number 8 we are creating FIFO. In line number 9 we are checking the error message. In line number 11 we written one debug message. On line number 13 we are opening the FIFO. In line number 15 just after the FIFO one debug statement. Okay, now we will execute. So before execute I will remove the pipe we already created. Now we'll compile P1. Oh, one second. So one header file is missed. I think yeah, we have to include fc and tl.h header file. One second. tl.h. Okay, clear. Now we will execute. No, sorry, I'm executing. We got executable file name called P1 because here we are creating like this. Now we will run P1. What will happen? Just see. Now see what I will open the code also for reversion. So in line number 8 we created. In line number 9 we got print message as success. Next in line number 11 we got print sorry, line number 11 print statement is there, that is nothing but before open file. So we got. Now see the output what's happening. Now see the output what's happening. Line number 13 is a blocking. Line number 13 is a blocking. Okay, if it is not a block, we will get this print statement also, right? If it is not in blocking state, we will get after open FIFO. But our code is stuck in line number 13. Why it is blocking? Why it is blocking? You got, I think you get the you get the point, right? Why it is blocking? In line number 9 we got mkfifo success. It means successfully FIFO is created. Then even though it is blocking, right? Why means this is very important concept. This is very important concept. I will tell you here. See, what's happening is, if you use system called mkfifo, a file is created here on hard disk. What's happening? P1 is opening the file in write mode. P1 is opening the file in write mode. In the code, see, just see. In the P1 is opening in the write mode. Right? At the time, what's happening? This open system call act as a blocking. Why means we already discussed it, right? We already discussed it in the overview of FIFO. File doesn't have any content. File doesn't have any content. The size of the file is 0. We already discussed, right? So why it is blocking means, the file is open in write mode, but somebody has to be open in read mode also. Okay, somebody has to be read mode also. Then only the open will unblock. Then only the open system call will unblock. Okay, so until other process won't open that file in read mode, it will be in block state only. Okay, that's why the open function now act as a blocking function. Now that's why open function act as a blocking function. Okay, see here P1 process just writing data. P1 process open a file. I will show the code here. In line number 13, P1 process open a file, pipe file in write mode, but this is the only one process open a file in write mode, but there is no other process to read the file. That's why it acts as a blocking function. Okay, why we have to open that file in read mode means it doesn't have any content. See, if you write also, it won't store in that file. So that's why that's why two process must open that file in read and write. Okay, I hope you got the point. Okay, now I will show you one more thing. Okay, we will create another process also. One second. Oh, sorry. Okay, so we will continue first. Let's see later. You got it right? Why it is blocking? If P2 process open that file in read mode, it won't act as a blocking. Okay, until the other process will open that file in read mode, that time it will act as a blocking. Okay, let's see what's the P1 task. It has to read data from the user. Okay, now that's why I'm creating one array of size 20. Next, printf Just I am reading data from user percentages comma as next. What you have to do, what I am doing after reading data from user, we have to put in FIFO. How to put? Just use a write system call. Just use a write system call. Right. What we have to pass? We have to pass three arguments. One is file descriptive. Next one is data. Next one is strlen, length of the data plus 1, because /0 also I am adding. Okay, this is clear, right? And now we will create P2 process also, so that's why I'm copying. Yeah, what are the changes? P2, it has to read the data from data from the pipe and print on the screen. So this is the task of P2. Next, so for this what we have to, for this task we have to open in read mode. So RD, for this we have to open in read mode. RD. Next thing what you have to do, just first we have to read. We don't want this thing, we are not scanning from user, just we have to read system call. We have to pass three arguments. One is file descriptor, second address of address where to store, next size of, yes, so how many characters we have to read, and next after reading what's the task, we have to print on the screen. Printf percentages comma yes. Okay, now we got two executable files, P1 and P2. Now I will, one second, I will open multiple terminals. One second, guys. In left side terminal I will execute P1. In right side terminal I will execute P2. Okay, now I am executing first P1. Okay, so in P1 what's happening? We already created, that's why we got file exits. Next, before open file, next what's happening? It is open function is a blocking function, because the P1 process opened the file in write mode, but no other process has opened the pipe in read mode. Now in right side I am executing that one. See, one second, something was here code is not updated here. Sure, one second. Previously it is open in multiple terminals, so that's why code is not updated. I am writing the P1 code. What's the P1 task? It has to read data from user by using scanf function and has to put in pipe FIFO. For writing the data into FIFO, what you have to use? We have to use system call of write. Clear? Clear. 1 second. Yes, and see the left side. Open function act as a blocking function because the file is open in only write mode. No other processes are opening in read mode. Now see right side. Yes, the file is open. That's the same file is open in read mode also. So that's why blocking is stopped. Next, it's asking the data from user. I'm giving hello. Okay. After taking the data from user, what P1 task is doing, it's writing into the FIFO by using write function. So here it will reading that function. Okay, so this is the task. So we achieved, right? P1 P2 are processes are running in another 10 minutes, even though we are sending data by using FIFO. It's also called as named pipe. I think, is it clear, right? So this is the basic task. This is the basic workflow of named pipe. Clear? Okay. So if you have any doubts, please reach out me. I will clarify you on this topic. Just please revise these things. Okay.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.